Hey class. There was one problem I didn't get a chance to get to in the lecture today because we spent time discussing about learning things even though a calculator and computer can do them. So I wanted to put this online in case it would be helpful for some of you. The problem we're going to do is sine squared theta d theta. And I'm going to make this actually a definite integral, so we're going to go from theta equals 0 to theta equals pi. This actually does have a physical interpretation. If you take the shape of sine from 0 to pi, and you make slices that are squares, so coming out of the screen, it's kind of hard to draw, then this would describe the volume of that solid. So, but how are we going to do this? I know some of you know one way using a trigonometric identity, but we haven't got to that yet in our class. But there is another way, and it teaches an important technique in solving some of these problems having to do with identities. So we're going to do this in terms of parts. I'm going to break this up. I'm going to think about this as sine times a sine. So sine of theta times sine of theta d theta. Now, it doesn't really matter which one I make u and v, so I'll take u equals sine of theta, du equals cosine of theta d theta, and then dv is sine of theta d theta, and so v will be a negative cosine of theta d theta. So out from that random line there. Try to fix that. Okay, so this integral then from 0 to pi of sine squared theta d theta equals uv, so a negative sine of theta cosine of theta. So the negative, the cosine over there is negative. I pulled that out front, minus the integral of v du. So v is a negative cosine of theta d theta. This integral v du, so times another cosine of theta d theta, and this is a definite integral, so this is going to go from theta equals 0 to theta equals pi, and this integral is from theta equals 0 to theta equals pi, and you can simplify that. And so that will look like a negative sine of theta cosine of theta from 0 to pi. The sine I can pull out, so I end up with plus cosine times cosine is cosine squared theta d theta. I'm still going from 0 to pi. And this doesn't look any better than what I had before. I was trying to figure out sine squared. Now I end up with a cosine squared. Well, if I don't know the sine squared, I probably don't know cosine squared. But I can get this into something using an identity. I can get this into something that has a sine squared in it. And then I can solve for the integral of 0 from 0 to pi of sine squared theta d theta. And that identity is cosine squared of theta equals 1 minus sine squared theta. So I could rewrite this as 1 minus sine squared theta d theta. And I'm going to write this as two integrals. Okay, so the integral of the difference is the difference of the integrals. So now I've got something that looks like this. And this looks pretty easy, about as easy as they come. So this will become just a theta going from 0 to pi minus going 0 to pi of sine squared theta d theta. But that is exactly what I'm trying to find. I'm trying to find that. That's what this side equals. Well, let's solve for that. I've got a negative 1 over here, I've got a positive 1 over there, I'm going to add 1 to both sides. So I'm going to end up with 2, 0 to pi sine squared theta d theta, and that equals a negative sine of theta. Oops, forgot some bounds here. Cosine of theta 0 to pi of 1, 0 to pi, plus a 1 there, and I had 2 of those, so I can divide by 2 over there. I can divide by 2 over here and evaluate it. So this side is now equal to my original problem I've been trying to solve, and that must be equal to 1/2 a minus sine. I'm going to plug in our bounds here, so minus sine pi cosine of, not theta, cosine of pi plus, I'm going to put all of my pi bounds in. At pi, that's just 1. So, and then, oops, it's not a 1, that's a theta. It should be theta. Okay, then minus a minus sine of 0, cosine of 0, plus a 0, and whole thing's multiplied by a half. I've got that already. Okay, well, sine of 0 is 0, so all those become 0. So I just have to focus on this side. Sine of pi is also 0, so these are 0. So I just end up with my 1/2 times my pi, so pi halves. So that is it. So a couple important things I want you to notice here. One, it is a definite integral that we've plugged in bounds here. I don't want to forget this first piece that that has the thetas. I need to evaluate that too. You don't have to write it this way, but you don't want to forget about plugging bounds into those. The other thing is, here I have, I end up with something that I can replace with an identity, and it helps me somehow. Either an identity and it gets me something that I know how to find the antiderivative of, or in this case, that it gives me a piece of exactly what I'm trying to solve for over here, and then I can bring it over and solve. So hopefully this also helps you understand some new strategies to work on these problems. Thanks.